remainder obtained when the same expression is divided by x minus 3. Find the value of p. According to the remainder theorem, when you divide by x plus 2, you put x plus 2 is equal to 0 and find its answer x equal negative 2. The remainder now is in the first part f of negative 2. You find the remainder when you divide by x plus 2 and find the remainder when you divide by x minus 3, which f of 3, and then make them equal because they are all, they said here, or he said, is equal to the remainder. So f of negative 2 substitute negative 2 cubed minus 5 into negative 2 squared minus 2p because x is negative 2 plus 6. Okay, you can simplify this value to be negative 2p minus 22. Okay, and find f of negative of positive 3. F of 3 now is 27 minus 45 plus 3p plus 6. You can simplify this expression to 3p minus 12. Okay, now put the two amounts are equal to find the value of p. 3p now minus 12 is the same as negative 2p minus 22. By collecting p in one side, you have 5p here, and here negative 22 plus 12, which is negative 10. Yes, so 5p is negative 10, implies p equals negative 2. So p is equal to negative 2. This is a solution. This is a value of p. Very easy and direct question. Come to number 15. This polynomial f of x show that x plus 4 is a factor. According to factor theorem, x plus 4 is a factor. X plus 4 is a factor of the polynomial, factor of f of x, if and only if f of negative 4 is equal to 0. So substitute in the polynomial f of negative 4 cubed minus 2 into negative 4 squared minus 19 into negative 4 plus 20. If you solve this by calculator, you will find it equals 0. Okay? Hence or otherwise, find all solutions of the equation. Here you can find all solution by dividing this polynomial by x plus 4, because now x plus 4 is a factor because f of negative 4 equals 0. When you divide x cubed minus 2x squared minus 19x plus 20 by x plus 4, you can simply use synthetic division. Just write the coefficient of the dividend, 1, negative 2, negative 19, and 20. And then divide this by the 0 of the divisor, which is negative 4. Just to bring 1 down, 1 times negative 4, the sum is negative 6. Time negative 6 times negative 4 is 24. The sum is 5. Just all add like this. 5 times negative 4, negative 20, the sum is 0. So the remainder is 0. This really enhances your answer. So the f of x, the polynomial, is really the divisor, x plus 4, times the quotient, the result of division. This is the result of division. This is the q of x, x squared. Just insert x squared here and x here and leave 5 as a constant term. So it's x squared minus 6x plus 5. Okay, write down x plus 4 again and try to factor this polynomial down. The x squared is x and the x. Don't forget we factor the trinomial by factor the first term and last term only, and you check the answer by the middle term. Don't forget. The x squared is x and the x. The 5 is, I'll make it negative 1 times negative 5. The middle term, I need it to be negative 6. And this is the answer. So the polynomial in factorial form is x plus 4 into x minus 1 into x minus 5. This polynomial is equal to 0. I want to solve it. Just to take each factor of these is equal to 0. You will get the solution as x equals a negative 4. Okay, x is equal to 1 and x is equal to 5, and these are the roots of the equation. Come to question number 16. You can stop the video anytime, as I told you before, and you can solve the question yourself, and then check your answer with me later. F of x equal this polynomial. Show that f of x is 3x minus 2 into something like that. Show that you can divide long division or synthetic division by 3x minus 2 to find the other factor, ax squared plus bx plus c. Let's revise the long division together now. Write the polynomial in the descending order as a for power of x. 6x cubed, I mean start with the biggest power of x, plus 17x squared minus 5x minus 6. Take this to divide it by 3x minus 2. Now divide the first term by first term. Look, how can you divide the first term by first term? 2x squared. Multiply back here. 6x cubed minus 4x squared. Now subtract. This is 0. 17 minus negative 4 is 21x squared. Bring negative 5x. Each time with the remainder, you bring only one term. Now 21x squared by 3x, the answer is 7x. Multiply back, you have 21x squared minus 14x. Yes? Now subtract, this is 0. Negative 5 minus negative 14 becomes negative 5 plus 14, which is 9. X, and they bring finally the 6. 9x divided by 3 is 3. 3 times 3x is 9x minus 6. Exactly, the remainder is 0. So this really, this polynomial really divisible by 3x minus 2, or 3x minus 2 is one of the factors of this polynomial. The other factors, you can simply write the polynomial now f of x as 3x minus 2 times the quotient. 3, not 3, I'm sorry. 2x squared plus 7x plus 3. Okay. 3x minus 2 into factor this 1 by writing 2x squared as 2x and x. The 3 you can write at 1 times 3. And here positive and positive. You have now 1x plus 6x is 7x. The middle term is correct. So this is number A now. I showed that by long division and finding the factorizing the quotient of the division, that the polynomial is really 3x minus 2 into the ax squared plus bx plus c. This is number A. Sorry, this is number A. Hence factorize, this is number B. Now, I'm sorry, this number B, the full factorization now is number B. I have 3 linear factors. X plus 3 into 2x plus 1 into 3x minus 2. Write down all real roots of the equation. This equation, when you put equal 0, f of x is equal to 0, if and only if. We really write this expression means if and only if 3x minus 2 is equal to 0. So x simply is 2/3, or 2x plus 1 is equal to 0. So 2x is negative 1, so x is negative half. And finally, the third factor here, this one, x plus 3 is equal to 0 implies x equals negative 3. So this is the answer of the solution. Okay, nice. Easy and direct question. You will not do any something hard. This chapter is very easy. Prove that x minus y over radical x minus radical y is equal to or congruent to root x plus root y. So if you start with the left hand side and write x minus y over root x minus root y, you can simply to remove this radical from denominator to just try to simplify. You multiply up and down by the conjugate number of denominator, which is radical x plus radical y. So really you are multiplying by amount is equal to 1 because the same number up and down. Okay. How can you multiply such a question? I advise you, in the numerator, don't multiply, just to keep x minus y may be simplified with a similar factor. Or if we need to multiply, no, we can later multiply. Okay? When you multiply root x minus y times root x plus y, you are really multiplying a minus b times a plus b in this form. You remember this algebra? The answer is a squared minus b squared. So the answer in denominator is really root x squared minus root y squared, which is x minus y. Yes? Root x squared, root x and root x is x. Now it's clear that you can cancel out um, the root x plus root y. You can cancel out now x minus y and x minus y, and you have to write that x is not y. When you cancel any algebraic method, algebraic expression from the algebraic fraction, you have to put this condition. X minus y is not 0, implies x is not y. So the answer really is radical x plus radical y, and this is the right-hand side. Okay, easy also question, nothing hard. Number 18, use complete the square to prove that n squared minus 8n plus 20 is positive for all values of n. Yeah, it's very easy. Just write n squared minus 8n plus 20 like this. You just complete square on this part. You remember complete square? Yeah, just this part, n squared and n, you just use these two terms to complete square. Just write n squared, just write it n. The same minus, just write it. Take half of 8 as 4. That's it, only that. And then make a square of this, all power 2, minus this number 4 squared, which is 16. The expression now I wrote, this one, is the same, this expression, n squared minus 8n. If you expand this, the one I wrote it now, if you expand it again on minus 16, you will get n squared minus 8n. And continue writing plus 20 here. So the expression now is n minus 4 all squared minus 16 plus 20 is 4. This expression now, you know that n minus 4, any number squared is really a non-negative value. It's bigger than or equal 0. If you add 4 to each side, so n minus 4 all squared, the plus 4 will be positive. Will be positive if you add 4 here and add 4 here. N minus 4 all squared now plus 4, which is the expression, the original expression I have, is bigger than 4. So it's a positive. All numbers bigger than 0 are positive, bigger than 1 is positive, bigger than 4 is positive. So the expression n squared minus 8n, the original expression, which is the same, this one, is bigger than 0, positive. Bigger than 4 means bigger than 0, of course. Any number bigger than 4 is bigger than 0, yes? Yeah, this is a language of logic. This is mathematics. Prove that the sum of two consecutive positive odd numbers less than 10 gives an even number. Okay. Less than 10, you can just take the consecutive odd numbers. 1 plus 3 is equal to 4. It's an even number. 3 plus 5 is equal 8. Also, it's an even number. 5 plus 7 is equal to 12. It's an even number. And finally, 7 plus 9 is equal to 16. Also an even number. These all are even numbers. In general, the sum of two odd numbers, not necessarily to said or to say less than 10. All each two consecutive odd numbers, the sum is even, of course. To do this mathematically, let the two numbers be or equals to n is always even number. For n is any value natural number. To n plus 1 will be an odd, of course. The next odd number will be 2n plus 3 because each odd number increased by 2 with the previous number. You know 1, 3, 5, 7 series of, or the sequence of odd numbers increased by 2. Yeah, increased by 2. Okay, so the sum of these two numbers, 2n plus 1 plus 2n plus 3. What happened if you add? You get 4n plus 4. And 4n plus 4, if you take 2 common factor, it will be 2n plus 2. If you succeed to take n common factor from an expression, this expression is the whole number, always whole number. So this number is divisible by 2. So is divisible by 2. Divisible by 2 means an even number. Divisible by 2, consequently, it's an even number. Okay? Thank you so much. Continue now, number 21. Prove that the statement n squared minus n plus 3 is a prime number for all values of n is untrue. Yeah, the values of n natural number, the values of n. If you put n1, you let n is equal to 1. What's the value of this expression? 1 squared minus 1 plus 3 is 3. N is equal to 2 implies 2 squared 4 minus 2 plus 3 is equal to 4 minus 2, 2 plus 3, 5. So now it's a prime number. And if you put any 3, look what happened. 3 squared 9 minus 3 plus 3. Oh, look, this is 9. 9 is not a prime number. 9 is not a prime. So this sentence is not true. Not always true. Sometimes true, sometimes not. Okay? So I proved now that this statement n squared minus 2n plus 3 is a prime numbers for all values of n is untrue. Yeah, it's untrue. Yeah, because I just substitute by n equal 3, I get a composite number. It's not prime. Look at this nice question. Prove that x minus 1 over x, okay, times x to the 4 over 3 plus x to the power negative 2/3 is congruent or equal to x power 1/3 into x squared minus 1 over x squared. To show this one, I start with the left hand side, okay, which is x minus. I just write here x power negative 1. I rewrite 1 over x power negative 1 times x to the 4/3 plus x to the negative 2/3. Okay, just I wrote it x to the negative 1 to facilitate the process of multiplication. Now use distributive property to multiply. X, start with multiplying this. X times x to the 4 over 3, x power 7 over 3, just add the power, plus x times x to the negative 2/3 is x power 1/3, and then minus x power negative 1 plus 4 over 3 is 4 minus 3 is 1/3, minus also x to the negative 1 times x to the negative 2/3. You sub negative, consider this one negative 3 over 3, negative 5 over 3. Okay, this is the answer. Now x root x, cube root of x power 1/3 minus itself is 0. So you have x power 7 over 3 minus x power negative 5 over 3. I want to rewrite this as this form. How? You have x power 1/3 outside. So I'll multiply by x power 1/3, look, outside, and multiply in the same time x power negative 1 over 3. This is negative 1 over 3 into this expression. So really I multiplied the original expression, this one, by 1, because x power 1/3 times x power negative 1/3 is really 1. Yes? Again, I'll multiply the expression I get from simplifying the left-hand side by once by x power 1/3 and other time by x power negative 1/3. So I did not do anything. The expression is still the same. But I have now x power 1/3 outside, the same as right-hand side. Now multiply x power. When you multiply, add the power, negative 1 plus 7 is 6 over 3, minus x power 3, so negative 1 plus negative 5 is negative 6. and this is simply x power 1/3 into x squared minus, this is x power negative 2. It's easy to write it as 1 over x squared, the same as the right hand side. Okay, continue to solve number 23. I think this is the last question. No, we have 24. 23, prove that this equal to this. Yeah, the same way, the same way. Look, you have factors already here. Look, you have x plus 4 is a factor, x minus 5 is a factor, and also 2x plus 3 is a factor. So simply take this expression divided by x plus 4, you will get the other two factors. Very easy. I use synthetic division here. Very easy. Look, 2. Write the coefficient only, the coefficient of the polynomial you have. 2, 1, negative 43, and negative 60. And write the 0 of the divisor. Is 0 of x plus 4 is negative 4. Be careful. Now bring 2 down. 2 times negative 4, negative 8. Just add negative 7 times negative 4 is 28. Just always add. Okay, always this way you add all numbers. The answer is negative 13 minus 8 is 5, and 3 minus 2 is 1. Negative 15 times negative 40 is 60. The sum is 0. Oh, perfect. The sum is 0. This is the remainder, of course, must be 0 if the polynomial is divisible by x plus 4. So the answer is the polynomial f of x is really the x plus 4, that the factor I divided by now, into the quotient. This is a quotient after inserting x squared here and x here. 2x squared minus 7x minus 15. You insert x squared here and x here, and just read this answer. This is a quotient. Very nice and very quick method. So x plus 4. You could try to factor this quotient into two linear expressions. 2x squared is really 2x times x. The 15, you can write it 3 times 5. When 3 wins 5, I think 5 here and the 3 here. To get negative 7, make negative 5 and positive 3. Now look, the middle term is correct. 2x times negative 5, negative 10x. And the 3 times x is 3x. The sum is negative 7x. Your answer is correct. Okay. So you proved now that the original polynomial is x plus 4 into 2x plus 3 into x minus 5. The arrangement of the factors is not important since multiplication is commutative. And finally, number 24, the equation x squared minus kx plus k is equal to 0, where k is a positive constant, has two equal roots. Prove that k is 4. This word, the equation has two equal roots. This means that the delta discriminant, which is b squared minus 4ac, must be equal to 0, because this equation has two equal roots. Don't forget the a is coefficient of x squared 1, the b is a coefficient of x is negative k, and the c is k. So substitute this value in this expression. You have k squared minus 4 into 1 into k is equal to 0. K squared minus 4k is equal to 0. Take k common factor, you have k minus 4. So k equals 0 either, or k plus 4 is equal to 0. This solution is rejected since k is positive. Look, k is positive value, so k0 is rejected or refused. So k here, the value of k is equal to negative 4. And I think that, sorry, this is minus, I'm sorry. This is k minus 4, not repeat this part again. This is really k minus 4, so adjusted k minus 4 is 0, so k is equal to 4, and this is the answer. Thank you so much, my students. I'm happy with you that I finished chapter review number 1, and inshallah I'll try to finish all chapters review with you. Thank you so much. Goodbye.